I'm gonna teach you how to build this game and run it in the browser using WebXR. First, let's create a URP project, and it's gonna be a 3D simple scene URP, so a bunch of stuff will come already set up for us in this case. Then we add the project name. I'm gonna say here WebXR, slap a cube, and clicking create project. Alright, after Unity loads everything, we need to install the packages we are gonna need. We have to go to Window, Package Manager, and we will add the De-Panther WebXR libraries. So we are gonna install these two. You will go to here in WebXR Export, then we are going to copy this URL, and we will add package from git URL. What we want, we're gonna paste it and add. Now we want to get the WebXR interactions, copy the URL, again add package from git URL and add this one. From this package here we will also want to import the sample scene, and after the import finishes we go to the project and then we go to samples, WebXR interactions, review, sample scene, scenes, desert. Gonna open this scene here. It is using built-in shaders, so we can fix that. Going to edit, render pipeline, universal render pipeline, then upgrade project materials. So in order for us to run this scene here in a headset in the editor, we need to install the OpenXR package. Then you have here OpenXR. Click install it. At the end of the installation, you're gonna be presented with this warning window here. It's basically saying to you that you have to migrate to the new input system, as the OpenXR uses that. So instead of migrating, we want to click in no. So we go to edit, project settings, then player, and then we go down to the other settings, input handling. We want to select both. Okay, we need both because in our case the WebXR and OpenXR in Unity use different systems. Let's enable the OpenXR in the XR plugin management, and also let's enable the WebXR export for WebGL builds. In the OpenXR tab, we need to set up the interaction profile, so in my case I'm using Oculus. Now let's try it. Oh, it lives! Now let's use the scene here to create our whac-a-mole-like game. Gonna hide the interactables. Let's create a cube. Come on, cube. Scale it down. Put it here. And let's make it a trigger. Let's make this table here whac-a-cube table. This guy here, let's create a button. It's gonna be the whack button. And another script that we are gonna call whac manager in the table. Inside the whack button script, we need for now a Unity event that is the onHit. For this, we need to use the Unity engine.events, and also we are gonna need the onTriggerEnter, and inside the onTriggerEnter, we want to call the onHit invoke. In the whack manager, we need a function to register the hit. For now, we will just print this string. We also need a list of whack buttons, and on the onEnable function, we want to iterate through all the whack buttons we have in this list and subscribe to the onHit unit event we have there. For now, we will use the register hit. So every time the onHit invoke is called, it's gonna call the register hit here. And on the onDisable, we want to unregister from that unit event just to avoid issues. Back in the editor, we want to duplicate this cube here, let's rename it properly. So whac button, and let's duplicate some more times. Now in the whac manager, we want to drag and drop all of these guys here to have a reference. So let's lock the inspector so it doesn't change. And then I'm gonna select all the whac buttons and drag and drop them here. Now we have the list filled out. And let's try it out. You can see that many events are being triggered at the same time. And this is mainly because the colliders we have in the hands are too big. Now let's fix it. Let's start with the right hand. In the model game object, we don't need the collider, and in the input model, let's reduce this to 0.7. That's reasonable. Now let's work the same thing on the left hand. And also let's separate these cubes here a little bit. Yeah, that's more like it. Now let's add a canvas here for us to show the scoring. It has to be in word space for us. Cool, now let's code the scoring system. So first, let's use the tmpro namespace since we want to add reference to the score text field, and also let's add one more field that is the best score text. Internally in the class, we will need to have a score integer and best score integer just to track the score and the best score of the player. In the register hit function, we will need to increment the score. Also, we want to print the new score and check for the best score. For the print score, we just want to add to the score text mesh pro the score variable as a string. And for the check best score, first we will test if the new score is greater than the best score, and if so, back in the editor, now we want to add the best score field to the canvas. And we want to add the references to these fields in the whac manager. So first best score, and then the score text itself. And let's test it. And it's working. So let's talk about our game loop here. It basically consists in the player starting the game, slapping things around, then at some point the time runs out, and then the player can choose to play it again. To close the game loop, we will have to control the time, add logic on how the game ends, and allow the player to start the game over again. So let us start by adding some variables. We need to track the time and show it to the player through the time text. We also want to set up the game time. So in this case, we will tell the player that he can play for 60 seconds. We will need a variable to say if the game has ended. Another one to track the time left to the player. And the last one is a coroutine we will use to track the time tick coroutine we are going to create. We are going to add a function that is the end game. For now, we just set the game ended as true. Add a function to print the time. So this here means that we don't want to show the decimals. We need a coroutine to control the time tick. In this, we are going to have a local variable tick. It's going to be 1 second. Then we need to instantiate a wait for seconds, and this is gonna be for 1 second. We need a start time float, and it's gonna be the time since the beginning of the game. We will iterate until the game is ended. So if this is true, saying the game has ended, this while loop here will stop. And inside the while loop, we want to calculate the game time left. The game time left minus the tick, so it's minus 1 second in our case. We will print this new time that is left to the player. And if the game time left reaches 0 or less than 0, so this means the game has ended because of the timer, then we will call the end game, and after this we will yield return wait. So this means after we do all of this, I want to wait for 1 second. Now let's create the reset timer function. Inside of it, we will test if we already have a coroutine created, so if we have a time ticking, and if we have, we want to stop that. After this, we will reset the game time left based on the game time we have set up there. Remember, 60 seconds. And after this, we will print the time again so we can show the next round time. Let's also create a start game function. Inside of it, we want to set the game ended as false, and we want to start the timer. Only for testing, I want to add this function here when the object is enabled. Back in the editor, we want to create the fields to show the timer to the player. Let's add the reference to this new field. And let's try it out. I will set the game time to 5 seconds so that we can test if it is working quicker. Alright, 3, 2, 1, 0, and it should stop. Very nice. So right now the game is pretty boring. Let's add some randomness to fix that. In the whack button class, we want to have a field to store the material we are going to use when the button is not activated, so when the button is normal. Another one to show the player when the button is activated. And we want also to track the mesh render, and we are going to use this to change from normal to active and vice versa. Also, we will need a boolean to represent when the button is active or not. We also want to add 2 new functions. The first one is the activate. In this, we want to change the material of the mesh render to the active, and we are going to set the active boolean to true. The other one is the deactivate function, where we will change the material to normal, and the active boolean will be set to false. In the onTriggerEnter, we want to add a test to check if the button is active, and then we will call the deactivate function. Also, the onHitInvoke will be called only when the button is active. So this means that we will only score if the button is activated. In the whack manager, we want to create a logic where we are gonna have these rounds, and between the rounds there will be some kind of delay. So for this, we need a variable called round delay, and for each round we want to activate a certain amount of buttons at the same time. And we want to set up the minimum active buttons here as 1 by default, but you can set up these in the editor, and maximum active buttons will be 3 for now. And internally, we need to control how many active buttons we have. And for this, we are gonna create this other variable here. In the register hit function, we want to add subtraction of the active buttons, and then we also want to test whether the active buttons have reached 0, and if so, we will call a coroutine we will create, that is the activate buttons. In the activate buttons, first we want to test if the game hasn't ended. Then we are gonna make a quick pause here using the round delay, there is 1 second. Then I want to have an amount of buttons, and this is a random number between the min active buttons and the max active buttons we have set up there. And with this amount of buttons, I'm gonna request for indexes from the list of whac buttons I have, okay? This list will be returned, and then we are going to iterate over this list, and for each index I will call the method activate from the button. So you see here I'm using the index, and after we activate, we will increment the active buttons variable we have in the class. In the row index function, first we need a list of integer, then an integer variable, and then we are gonna loop the logic here inside until we have all the indexes we requested in the amount. The first thing we're gonna do is to roll an index from 0 to the maximum amount of buttons we have. Then we are gonna test whether we already have rolled these indexes, so we don't want to repeat the same index of a button. If this is a new index, then we add to the list, and at the end we will return the list of indexes we have generated. And then you're gonna ask yourself, what the f did I just saw? Let me try to explain. First, we need to generate a random number. Let's suppose 3 in this case. Then we ask the row index function to generate us 3 distinct indexes based on the whac buttons we have there. So instead of giving us a rabbit, we're gonna receive an index for a whac button. This function will roll the dice until we have all the 3 distinct indexes, and after that we just activate the respective buttons. Back in the editor, let's create the materials we're going to use for the normal and the activated buttons. And now let's assign these materials to the whac buttons. And assign the mesh renderers. And also let's change the material we have in the buttons to the new one we created. There is a little trick we can use to rumble the motion controllers when we collide with these whac buttons. We can just change the tag here to interactable. That will do it. Cool, now let's try it out. The last issue is that we don't have a way for the player to play again. Let's fix that. In the whac manager class, first we will create a new function called reset table. Inside of it, we will iterate through all the whac buttons we have created and assign it to the manager, and we will ask them to be deactivated. The other function is the reset score, where we will first zero out the score, then the active buttons, and then we are gonna ask to print the score again. Pay attention that we are not resetting the best score, since we wanna keep that for the player to have a reference. In the start game function, we want to call the reset table and also the reset score. In the scene, we want to add one more cube that will trigger the start of the game. In this cube here, I want to create a new script just to help us to call the start game function from the whac manager. Let's call it button event. Inside the button event script, we want to use the Unity engine events, and then we'll create a new property here that is onPress, a Unity event. And then we need the onTriggerEnter, and in case we register any collision here, we will call the onPress invoke. Let's save it and go back to the editor. Just add one event here, drag and drop the whac-cube table. This game object has the whac manager, and we want to call the start game from the whac manager. Now you see the time has ended, and when I press the button, the game starts over again and we keep the best score. Congratulations, you have developed your first WebXR game. Now let's go to the deploy phase. Before we deploy, we have to build the project. So go to File, Build Settings, make sure we have our scene here inserted. So let's put Add Open Scenes. I want to uncheck this one, and we will change to WebGL platform. After the switching finishes, let's go to the player settings, player. In the WebGL tab, we want to look for the resolution presentation. Here we only have the standard WebGL templates. We have to use the WebXR web templates. To do so, let's close here, go to Window, WebXR, copy WebGL templates. Let's go back to the player settings. There we go, we have here the WebXR. I'm using Unity 2020, so I will go with this full view 2020. We don't need to fill out the other fields. Make sure the WebXR is set up here correctly, and in the XR plugin management, in the WebGL tab, you have the WebXR export checked. With that out of the way, we can click in build. I will create a new folder here and select it, and now wait for it to finish. After the build is done, we are not able to execute here using Unity's localhost server. So we need to have a server that is HTTPS. You have two options. You can install an HTTP server in your machine and then you can execute there, or a quicker way just for you to feel the WebXR for the first time is create a new project here in itch.io. Make sure the project is set to private or restricted, and then let's type here test WebXR. I'm gonna go back to that folder where I have the build, and I will zip these files here. Let's call it WebXR snap a cube. Then we can go to the website here, upload files. I have here the zip file. It's gonna upload, and meanwhile you can go to the kind of project and say it's HTML. So we want to execute in the web browser. The upload has finished, and we can mark here this file will be played in the browser. Let's mark it, and then we can save and view the page. It's loading the game, click in run game, and after that you can put your headset and click in the VR. The best browser to execute WebXR experiences is the Firefox by far, since the WebXR was originally called WebVR, and then we had De-Panther working and improving with some other folks the library and even extending it. Folks, thank you so much for watching. Make sure to subscribe, and if you enjoyed, please leave your like here in the video. And if you want to download the project, you can find the link to it in the video description. Have a nice one.